Write the following quadratics in vertex form. State the vertex and transformations that occurred to each parent function. So we're going to start by subtracting 46 from both sides. And I like to write negative 46 plus y. There's nothing wrong with writing y minus 46 equals x squared minus 12x. The nice thing on this particular problem is that there's no number in front of the x squared term, so we don't have to worry about that. We can go straight to adding in our box to both sides. So we're going to add box, and we're going to add box. To figure out what goes in the box, negative 12 divided by 2 squared, and whatever we put in that box, we're going to put in this box. Negative 12 divided by 2 squared. We can simplify that. Negative 12 divided by 2 is negative 6 squared minus 46 plus y. And over here this is x squared minus 12x plus negative 6 squared. Well, I write it in this format because we've just completed the square. And what that means is we've created a perfect square trinomial. So what goes in these two parentheses has to be the same value. X squared is x times x. Negative 6 squared is minus 6 minus 6. The negative 12x is hidden in these two parentheses. And over here on the other side we can start simplifying. Negative 6 squared is 36. If you need to type that into your calculator, then make sure you put parentheses around there. We can condense over here and we get x minus 6 squared, and 36 minus 46 is negative 10. And the last step here is that we want to solve for y, so we're going to add 10 to both sides, and we get y equals x minus 6 quantity squared plus 10. Our turning point, change the sign, keep the sign, is 610. And our transformations. Well, minus 6 means that we moved right 6. It's inside, that minus 6 is inside the parentheses, so it goes the opposite direction that we think it's going to go. And then plus 10 goes the direction we think it's going to go, which is up 10. Same idea here on problem B. We're going to start by moving the 17 to the other side. We get negative 17 plus y equals 2x squared plus 36x. The difference on this particular problem is that we've got a number in front of the x squared. So our next step is that we have to factor out that 2. 2x squared divided by 2 is 1x squared. 36 divided by 2 is 18x. And now we can add our box. But don't forget this. This was 2 times x squared to give us 2x squared. 2 times 18x gives us the 36x. So this has to be 2 times box. So over here on the other side, this has to be 2 times box. Once we have it set up, now everything else is the same. We're going to look at this number, which is in front of the box. Positive 18 divided by 2 squared. So same thing going to be over here. Positive 18 divided by 2 squared. If we simplify that, 18 divided by 2 is 9 squared minus 17 plus y. And again, same value in this box here. 18 divided by 2 is 9 squared. We've just completed the square, adding the same number to both sides, and now we're going to factor. The 2 stays there, then we've got our 2 parentheses that need to be the exact same value. And in order to avoid splitting the middle, I write it in this format. X squared is x times x. 9 squared is 9 times 9. 9 is positive, so these are both added. We can start to simplify over here on the other side. This is 2. 9 squared is 81. 2 times 81 minus 17 plus y. But we can condense over here, and it's 2 times x plus 9 squared. 2 times 81 is 162 minus 17. And you can type that into your calculator. In fact, I need to type in the 162 minus 17 to get the 145 plus y equals 2 times x plus 9 squared. And then lastly, we're going to move the 145. We're going to subtract the 145 because we're solving for y. We're writing this in vertex form. We went from standard to vertex form, by the way. And it's 2 times x plus 9 squared minus 145. Our turning point. Change the sign, keep the sign. Negative 9, negative 145. This too actually does do something to the graph. Ask your Algebra 2 teacher about that. We are going to talk about it in a later lesson. But our transformations that we're familiar with right now, since we have x plus 9, we're going to move our graph left 9. And then the minus 145 is going to move our graph down 145.